In the last session, we have discussed about the classification of polymers on the basis of their physical structure. We have seen the linear polymer. Linear polymer is one which is formed by repeatedly joining the monomer and its structure is linear. Only bifunctional monomers can form linear polymer. ಒಂದು ಕ್ರಾಸ್ ಲಿಂಕ್ಡ್ ಪಾಲಿಮರ್ ಇಲ್ಲಿ ಪಾಲಿಮರ್ ಚೈನ್ಗಳಿರ್ತವೆ ಬೇರೆ ಬೇರೆ ಈ ಚೈನ್ಗಳನ್ನ ಅಟ್ ಸರ್ಟೆನ್ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಅದನ್ನ ಕ್ರಾಸ್ ಲಿಂಕ್ ಮಾಡಿದೆ ಒಂದು ಪಾಲಿಮರ್ ಚೈನ್ಗೆ ಇನ್ನೊಂದು ಪಾಲಿಮರ್ ಚೈನ್ ಅನ್ನ ಹಾಗೆ ಅದಕ್ಕೆ ಮತ್ತೊಂದನ್ನ ಹಾಗೆ ಅಲ್ಲಲ್ಲಿ ಅದನ್ನ ಲಿಂಕ್ ಮಾಡಿರ್ತಾರೆ ಅದರಿಂದ ಇದಕ್ಕೆ ಎಲಾಸ್ಟೊಮರಿಕ್ ಪ್ರಾಪರ್ಟಿ ಮತ್ತು ರಬ್ಬರಿ ಪ್ರಾಪರ್ಟಿ ಬರ್ತದೆ ಆಯ್ತಾ ಅದು ಆ ಚೈನ್ ಸ್ಲಿಪ್ಪೇಜ್ ಆಗೋದಿಲ್ಲ ಅದರಿಂದ ಒಂದ್ಸರಿ ನೀವು ಆ ಕಡೆ ಎರಡು ಕಡೆ ಅದಕ್ಕೆ ಫೋರ್ಸ್ ಹಾಕ್ಬಿಟ್ಟು ಎಳೆದ್ಬಿಟ್ರೆ ರಬ್ಬರ್ ಡಿಫಾರ್ಮ್ ಆಗ್ತದೆ ಇದು ಡಿಫಾರ್ಮೇಶನ್ ಆಗಬಾರ್ದ್ರೆ ಆಗೋದು ಯಾಕೆ ಅಂದ್ರೆ ಅದಕ್ಕೆ ಕ್ರಾಸ್ ಲಿಂಕೇಜ್ ಇರೋದಿಲ್ಲ ಪಾಲಿಮರ್ ಚೈನ್ಗೆ ಆ ಪಾಲಿಮರ್ ಚೈನ್ ಅನ್ನ ಕ್ರಾಸ್ ಲಿಂಕ್ ಮಾಡಿದ್ರೆ ನೀವು ಎರಡು ಕಡೆ ಹಾಕಿದ ಪ್ರೆಷರ್ ಅನ್ನ ನೀವು ರಿಲೀಸ್ ಮಾಡಿದ್ರೆ ಇಟ್ ವಿಲ್ ಕಮ್ ಟು ಇಟ್ಸ್ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಎಲಾಂಗೇಟ್ ಈಗ ಎಳೆದ್ರೆ ಎಲಾಂಗೇಟ್ ಆಗುತ್ತೆ ಆಮೇಲೆ ಅದನ್ನ ಬಿಟ್ಟರೆ ಅದು ಇಟ್ಸ್ ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ ಬರ್ತದೆ ಅದು ಎಲಾಸ್ಟೊಮರಿಕ್ ಪ್ರಾಪರ್ಟಿ ಅದು ಸಿಗಬೇಕಾದ್ರೆ ನಿಮಗೆ ಪಾಲಿಮರ್ ಚೈನ್ಗಳು ಕ್ರಾಸ್ ಲಿಂಕ್ ಆಗಿ ಇರಬೇಕು ಇನ್ನೊಂದು ಬ್ರಾಂಚ್ ಚೈನ್ ಪಾಲಿಮರ್ ಅಂತಿದೆ ಅದರಲ್ಲಿ ಇದು ಬೈ ಫಂಕ್ಷನಲ್ ಮತ್ತು ಟ್ರೈ ಫಂಕ್ಷನಲ್ ಮಾನೋಮರ್ಸ್ ರಿಯಾಕ್ಟ್ ಆದ್ರೆ ಆಗ್ತದೆ ಪಾಲಿಮರ್ ಚೈನ್ ಒಂದು ಚೈನ್ ಮೇನ್ ಚೈನ್ ಇರ್ತದೆ ಅಲ್ಲಿಂದ ಅದು ಮತ್ತೆ ಬ್ರಾಂಚ್ ಆಗಿ ಮತ್ತೆ ಬೇರೆ ಪಾಲಿಮರ್ ಚೈನ್ ಶುರು ಆಗ್ತಾ ಇದು ಚೈನ್ ಶುರು ಆಗುತ್ತೆ ಅದು ಮತ್ತೆ ಬ್ರಾಂಚ್ ಆಗಿ ಮತ್ತೆ ಹಾಗೆ ಬ್ರಾಂಚ್ ಬ್ರಾಂಚ್ ಆಗ್ತಾ ಹೋಗ್ತವೆ ಅದನ್ನ ಬ್ರಾಂಚ್ ಚೈನ್ ಪಾಲಿಮರ್ ಇನ್ನೊಂದು ಇಲ್ಲಿ ಪಾಲಿ ಕಂಡೆನ್ಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಮತ್ತು ಎಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಇದೆ ಪಾಲಿ ಕಂಡೆನ್ಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ನಿಮಗೆ ಮಾನೋಮರ್ಸ್ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಪಾಲಿಮರೈಸೇಷನ್ ಫಾರ್ಮ್ ಆದಾಗ ಎ ಸ್ಮಾಲ್ ಕ್ವಾಂಟಿಟಿ ಸ್ಮಾಲ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ವಾಟರ್ ಅಮೋನಿಯಾ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಎನ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಇಂಥದ್ದೇನಾದರೂ ಒಂದು ಬೈ ಪ್ರಾಡಕ್ಟ್ ಸಿಗ್ತದೆ ಆಕ್ಚುಲಿ ಎಕ್ಸ್ಪೆಲ್ಸ್ or eliminates the small molecules of these water, ammonia, formaldehyde or NaCl. ಇದು ನಿಮಗೆ ಆಗುವಂತದ್ದು ಪಾಲಿ ಕಂಡೆನ್ಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಎಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಏನು ಇದು ನಿಮಗೆ ಬೈ ಪ್ರಾಡಕ್ಟ್ ಇಂಥದ್ದು ಏನು ಆಗೋದಿಲ್ಲ ಏನು ಎಲಿಮಿನೇಟ್ ಆಗೋದಿಲ್ಲ ಎಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ನಿಮಗೆ ಸ್ಟೆಪ್ ವೈಸ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ ಚೈನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ ಅಯಾನಿಕ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ ಸ್ಟೆಪ್ ವೈಸ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ನಿಮಗೆ reaction takes place by step and whereas in chain reaction the addition reaction the polymer is formed in a single step within a fraction of a second the chain kinetics occurs in 4 steps initiation propagation transfer and termination ಸುಮ್ಮನೆ ಎರಡು ಮಾನೋಮರ್ಸ್ ನ ಒಟ್ಟಿಗೆ ತಂದ್ರೆ ಅದು ನಿಮಗೆ ಪಾಲಿಮರೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಆಗೋದಿಲ್ಲ unless you initiate the polymerization reaction. Initiation ಮಾಡಬೇಕಾದ್ರೆ we require some energy. That energy is usually supplied by thermal energy or alpha, beta, gamma. ರೇಸ್ಗಳನ್ನು ಕೂಡ ನಿಮಗೆ ಅದನ್ನ ರೇಡಿಯೇಟ್ ಮಾಡಿ ಅದರಿಂದ ರೇಡಿಯೇಷನ್ ಎನರ್ಜಿನ ಕೂಡ ಯುಟಿಲೈಸ್ ಮಾಡಿ ಇನಿಷಿಯೇಷನ್ ಮಾಡ್ಲಿಕ್ಕಾಗುತ್ತೆ ಸರಿ ಪಾಲಿಮರೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಇನಿಷಿಯೇಷನ್ ಆದ್ರೆ ನೆಕ್ಸ್ಟ್ ಅದು ಪ್ರೊಪಗೇಷನ್ ಆಗುತ್ತೆ ಪಾಲಿಮರ್ ಚೈನ್ ಆಗ್ತಾ ಆಗ್ತಾ ಪ್ರೊಪಗೇಟ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ ಆಮೇಲೆ ಪ್ರೊಪಗೇಷನ್ ಆದ್ಮೇಲೆ ಚೈನ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಬೇಕು ಚೈನ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಬೇಕಿದ್ರೆ ನಿಮಗೆ ಈ ಆಕ್ಟಿವ್ ರಾಡಿಕಲ್ಸ್ ಏನು ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೆ ದಟ್ ವಿಲ್ ಬಿ ಟೇಕ್ ಪಾರ್ಟ್ ಇನ್ ದಿ ಪಾಲಿಮರೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಅಂಡ್ ಬ್ರಾಂಚಸ್ ವಿಲ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್ ಹಾಗೆ ನಿಮಗೆ ಚೈನ್ಗಳು ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತಾ ಹೋಗ್ತವೆ ಅಂಡ್ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಇಸ್ ಟರ್ಮಿನೇಷನ್ ಯು ಹ್ಯಾವ್ ಟು ಟರ್ಮಿನೇಟ್ ದಿ ಪಾಲಿಮರೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಒಂದು ಟರ್ಮಿನೇಟ್ ಆಗೋದು ಹೇಗೆ ಅಂದ್ರೆ ಎಲ್ಲ ನಿಮಗೆ ಮಾನೋಮರ್ಸ್ ಕನ್ಸ್ಯೂಮ್ ಆದ್ರೆ ಪಾಲಿಮರೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಪಾಲಿಮರೈಸ್ ಆಗಿ ಆಗೋದು ಸ್ಟಾಪ್ ಆಗುತ್ತೆ ಇಲ್ಲದ್ರೆ ವಿ ಹ್ಯಾವ್ ಟು ಆಡ್ ಸಮ್ ಏಜೆಂಟ್ಸ್ ಕೆಮಿಕಲ್ ಏಜೆಂಟ್ಸ್ ಟು ಸ್ಟಾಪ್ ದಿ ಪಾಲಿಮರೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಟು ಟರ್ಮಿನೇಟ್ ದಿ ಪಾಲಿಮರೈಸೇಷನ್ ರಿಯಾಕ್ಷನ್ ಟರ್ಮಿನೇಟ್ ಮಾಡಬೇಕು ವಿ ಹ್ಯಾವ್ ಟು ಆಡ್ ಸಮ್ ಕೆಮಿಕಲ್ ರೈಟ್ ಇದನ್ನ ನಾವು ನೋಡಿದೀವಿ ನೆಕ್ಸ್ಟ್ today we will discuss about the classification of polymers according to their preparation method. Classification according to preparation method. Polymer ಅನ್ನ ಕ್ಲಾಸಿಫೈ ಮಾಡೋದು ಅದರ ಪ್ರಿಪರೇಷನ್ ಮೆಥಡ್ ಇಂದ. ಇದರಲ್ಲಿ ಎರಡು ಟೈಪ್ ಇದೆ, ಆಯ್ತು, ಟೂ ಕ್ಯಾಟಗರೀಸ್. ಒಂದು ಕಂಡೆನ್ಸೇಷನ್ ಪಾಲಿಮರೈಸೇಷನ್ ಮೆಥಡ್ ಅಂತ ಹೇಳ್ತಾರೆ, ಇನ್ನೊಂದು ಎಡಿಷನ್ ಪಾಲಿಮರೈಸೇಷನ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಇಂದು ಕಂಡೆನ್ಸೇಷನ್ ಪಾಲಿಮರೈಸೇಷನ್ ಅಲ್ಲಿ ನಾವು these methods are usually employed for low molecular weight functional group reactions, where stoichiometric proportion of reaction are fixed for the desired final product. During processing, solvent addition may or may not be important. These reactants are usually mixed in a batch reactor with controlled temperature and addition of catalyst. Vacuum processing or azeotropic distillation may be employed to remove condensation products such as water to obtain a higher degree of polymerization. In addition polymerization method, it is further classified as A, we already discussed. The addition polymerization reaction or polymerization method is further classified as a block polymerization. In this mode of polymerization may be employed to obtain the purest form of polymer, and the greatest yield of polymer per unit volume may be obtained using this method. This method involves only the monomer molecule, an initiator, and a chain transfer agent if necessary. In a large-scale batch form, the process is to be run slowly or in continuous mode with large heat transfer area. Casting of objects of various shapes may be accomplished using the batch bulk polymerization. Using continuous bulk polymerization process, polystyrene and other thermoplastic compounds may be molded. Bulk large scale production ಮಾಡಬೇಕಾದ್ರೆ ನೀವು bulk polymerization use ಮಾಡ್ತಾರೆ. Second one is solution polymerization. An inert solvent is added to the reacting components in the reaction vessel. In this process, the solvent enhances the heat capacity, thereby reducing the viscosity and facilitating heat transfer. Some of these solvents may be refluxed to remove the heat from the reaction vessel, but much of the reactor space is taken up by the solvent. As such, compared to bulk polymerization, solution polymerization reduces both the reaction rate and the molecular weight of the compound. Additional batch and continuous processes are used to separate the final polymer product and to recover and store the solvent. This is actually solution polymerization. Then next step is next method of polymerization is suspension polymerization. In order to control the enormous amount of heat release in bulk polymerization, suspension polymerization method was developed. ಯಾಕೆ ಡೆವಲಪ್ ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ ಸೊಲ್ಯೂಷನ್ ಪಾಲಿಮರೈಸೇಷನ್ ನಲ್ಲಿ ಅಥವಾ bulk polymerization ನಲ್ಲಿ ಏನು ಹೀಟ್ ಇವಾಲ್ವ್ ಆಗ್ತದ ಆ ಹೀಟ್ ಅನ್ನ ಕಂಟ್ರೋಲ್ ಮಾಡಲಿಕ್ಕೆ ಅವರು ಸಸ್ಪೆನ್ಷನ್ ಪಾಲಿಮರೈಸೇಷನ್ ಮೆಥಡ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ದಾರೆ. ದಿ ರಿಯಾಕ್ಷನ್ ಮಾಸ್ is dispersed as a minute droplets of size 0.01 to 0.01 to 1 mm in diameter in a continuous aqueous phase. Each of these droplets acts as tiny bulk reactors. Heat transfer occurs from the droplets to the water having large heat capacity and low viscosity. Cooling jackets are used to facilitate for the heat removal, and agitators are used along with suspending agents in an aqueous phase in order to maintain the specific droplet size and their dispersion. The suspension polymerization process cannot be run in a continuous mode since such a system has stagnant corners where polymer accumulation may occur. On a commercial scale, suspension polymerization is carried out in jacketed stainless steel or glass lined stirred tanks which may have a capacity of 20,000 gallons to 75.5 meter cube volume. Suspension polymerization process: small uniform polymer spheres are formed. These are used directly or may be extruded and chopped to form larger molded pellets. This is about suspension polymerization. ಇನ್ನೊಂದು emulsion polymerization ಅಂತ. In emulsion polymerization, the polymers are formed in the emulsion. This is the most commonly used method of polymerization. This process overcomes the difficulty of heat control and low degree of polymerization. The organic reaction mass is emulsified with soap in a continuous aqueous phase. The dispersed particles are smaller in size than in suspension polymerization, less than zero point 0.1 micrometer. In addition, due to stabilizing action of soap, the emulsion obtained is stable and agitation may not be necessary. In some methods, a water-soluble initiator may be used to initiate the polymerization reaction. The main product of emulsion polymerization is latex, which forms the basis of the popular latex paint. By coagulating the latex with ionic salt and acids, solid rubber may also be obtained. So this is about the emulsion polymerization. And fifth one is homogeneous polymerization. In this homogeneous polymerization, bulk polymerization takes place. The feed is a gas, liquid, or solid monomer. No initiator or additives are used. Once the one of the major difference between the elastomer and the polymers. Homogeneous solution polymerization, the monomer is completely dissolved in a solvent. Homogeneous polymer solvent monomer ಅನ್ನ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಅದರಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡ್ತಾರೆ. And next one is heterogeneous polymerization. Here, in heterogeneous emulsion polymerization, the monomer molecules are emulsified in an aqueous media in the form of micellars. For heterogeneous suspension polymerization, the monomer is suspended in, in an aqueous or other type of media as large droplets. As large droplets. Next, we will discuss about the classification according to their physical properties. The polymers can also be classified according to physical properties as thermoplastic, thermosetting polymers, elastomers, and fibers. Thermoplastic, thermoplastics. The polymers in this category are composed of monomers with a linear or have moderate branching. They can be melted repeatedly and cast into various shapes and structures by the application of heat and pressure. They are soluble in solvent but do not have appreciable thermal resistance property. For example, vinyls, cellulose derivatives, poly polythene, polypropylene, polystyrene, all these falls under this category of thermoplastic. Thermosetting materials, these are the materials or polymer products which are actually requires heat and pressure for shaping the articles from this. But once the article is shaped, it cannot be remelted or and reshaped. On heating, it actually breaks and the polymer cannot be reused. These are some polymers which, when heated, decomposes and hence cannot be reshaped. Such polymers have a cross-linked or branch-linked structure and are called thermosetting polymers. They are generally insoluble in solvent and have good resistance quality, that is heat resistance quality. Thermosetting polymers include phenol formaldehyde, urea formaldehyde, silicones, and alloys. Next, elastomers. These are resistant solids which have considerable flexibility. They are composed of polymers with glass transition temperature below room temperature. One major difference between elastomer and plastic is that elastomer is in a liquid state while plastics are in gaseous state. For example, of elastomer are butadiene copolymer and their derivatives, polycondensation product, silicones, thiocols are the examples of elastomers. Fibers, these are solids which can form thread-like structure and have high tensile strength. For example, for example, fibers are polyamides, polyester, polyurethane are the examples of fibers. Next, we will discuss about the classification according to the applications. On the basis of applications, polymers can be further classified as number one, adhesives. ಗಮ್ಮಾಗಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ adhesive. Some polymers can be used for bonding. They are usually of resin type and requires some water resistance. Some common adhesives are cellulose adhesives, which consist of cellulose derivatives dissolved in a solvent, for example, Duco cement. Vinyls, these are the rubber based type water emulsified latex adhesives. Apart from these, some cheap natural products such as starch, dextrine, proteins, and natural rubber may also be used for adhesive formulation. Next, coating and films. A large bulk of the polymers produced are used for manufacture of coatings and films. Free films of polyethylene and cellulose types, protective and decorative coatings are the products of polymer industry. Coatings can be manufactured by solvent evaporation followed by polymerization. Emulsion and casting or extrusion of free film by mechanical method can also produce coating of films. Next, third one, fibers. These are formed by extrusion or spinning of linear monomer molecules into a thin section of diameter in the range of 10 to 50 microns. Fibers having excellent tensile strength, creep, and resilience. Fibers are extensively used in the textile industry. Cotton and wool, etc., are the examples of some natural fibers. Next, we will discuss about processing, polymer processing. Various compounding processes are one, mixing. Polymers before casting, it has to be into required article, mixed or compounded. Right? That first step is mixing. Mixing follows obtaining a homogeneous mixture of polymer and other additives added to the polymer. The additives is distributed uniformly throughout the crude polymer without any unnecessary stressing. Mixing can occur under the action of gravitational force in a tumbling mixer or in a ribbon mixer, where materials are mixed in a horizontal barrel in a spiral manner. Such mixers are collectively known as cold mixers. Another class of mixers are the hot mixers, wherein the polymers are heated by contact with heated metal components. Such mixers are also known as high speed or turbo mixers. This method is widely used in plastic industry, especially in the compounding of polyvinyl chloride (PVC). is about mixing. Next, rolling and kneading. Before processing, the plastics are compacted, melted, homogenized, and modified with additives. These include rolling, in which the plastic is passed between two counter-rotating heated rolls wherein it is pressed into a thin layer. It is an open process in which can be added and other scrap material may be reintroduced. PVC, that is polyvinyl chloride, is one plastic which extensively employed in this process. Moreover, the material's temperature can be controlled precisely and cleaning of the machine is easy. Next step is pelletizing. In pelletizing, it is the method of producing granules of equal size and shape, which enables the optimum feed behavior in processing equipment. Pelletizing can be done in hot or cold conditions. Using pelletizing die, ribbons or steels are formed and after solidification they are chopped into the desired shape. This is one procedure strictly followed in cold pelletizing process. However, hot pelletizing, the plasticated material is sent through a die and a blade that rotates on the surface of the die plate chops the exiting strands. The melt is then cooled and subsequently the water is removed. Next step is shredding and grinding. In thermoplastic processing, a variety of semi-finished and finished products are generated. These products, in order to be made suitable for processing, must cut to produce pellets form. A range of pellet particle size is obtained in this process. Regulations Regulation is achieved through cutting mills. The material is added through a feed system wherein a rotor revolves with high momentum. The system is further equipped with multiple cutting heads that operates against stationary cutting edge. A rotating cutting heads are divided and displaced with respect to each other in some other machines. As soon as the desired particle size is obtained, the material is ejected through the sieve, the force of which determines the size of the particles. Housing and rotor may be equipped with water cooling apparatus to remove the excessive heat generated. And fifth compounding process is storage and transportation. The storage and transportation of these polymers and intermediate products are achieved through automatic equipment. These equipments have an edge over the manual operated one as they ensure improved working conditions, lower workplace, lower contamination of material, and subsequent reduction losses. Moreover, accident hazards are also reduced by this. Large external silos are used for the storage of polymer either in powder form or in the pellet form. By incorporating vibrating frames, bunker cushions, slotted sleeves, or similar techniques as ventilation, the formation of granule bridges is avoided. The materials are transported via road or rail. Reserve materials are and additives are transported in ship, in bulk containers, drums, or sacks. Pneumatic equipment generally preferred for conveying the powder and pellets. The conveyors used may be high pressure conveyors, medium pressure conveyors, and low pressure conveyors. Fill level sensors helps in controlling the transport intervals. In order to meet in order to meter the liquid such as plasticizers or other addition for compounding, oscillating displacement pumps are used. Metering of solids can be done using gravimetric metering equipment or volumetric metering equipments. So this is about the various compounding processes that are used in the polymer industries. Next we'll see some of the MCQs in this session. Number one, polystyrene is made by dash polymerization. Polystyrene is made by dash polymerization. Option A, solution. Option B, bulk. Option C, suspension. And option D, emulsion. The right answer is option B, that is bulk polymerization. Question number two, in homopolymerization, the monomer is completely dissolved in dash. Option A, solution. Option B, solvent. Option C, dehydrating agent. And option D, water. The right answer is option B, that is in a solvent. Question number three, an example of thermoplastic polymer is dash phenol formaldehyde, B polypropylene, C silicon, D thiocalls. The right answer is polypropylene, answer solution B. Question number 4, to get homogeneous mixture of polymer and additives, dash mixture is used. Options are A agitated, B ribbon, C spiral, and D none of these. Option B is the right answer, that is ribbon mixers are used in the polymer industry to get the homogeneous mixture of polymer. Fifth one, polymer fibers are produced by dash. A compression molding, B injection molding, extrusion, and D casting. Right answer is answer C. Sixth one, silicon is dash thermoplastic, an inorganic polymer, a monomer, none of these. Your answer is option B. Right. Thank you.